Hello and welcome. If you're getting ready for your OCR GCSE computer science exam, you are in the right place. We are going to break down one of the most important data structures you need to know, arrays. Let's just jump right in.
So here's the plan for today. We'll start with a real-world problem to see why arrays are even a thing. Then, we'll introduce what they actually are, break down the two main types you'll see, that's one-dimensional and two-dimensional, and we'll wrap up with the exact syntax you've got to know for that exam. Okay, let's get into it.
All right, first up, the high score problem. Before we get buried in definitions, it's so much more useful to understand the kind of problem that arrays were invented to solve. So, let's imagine for a second, you're a programmer. You've just coded an awesome game, and now you have to figure out how to store the top 10 high scores. How are you actually going to do that in your code? Just think about it for a sec.
Well, your first thought might be, I'll just create 10 different variables. Score 1, score 2, score 3, all the way to score 10. But just look at that. It's already getting pretty messy. And what if you wanted the top 100 scores or 1,000? No way. This method is just clumsy and super inefficient. There has to be a better way.
Well, you guessed it, that brings us neatly to Section 2, introducing the array. This is the clean, powerful, elegant solution to our messy high-score problem. So what is an array really? It's basically a special type of container. It's a data structure that lets you group a whole collection of related items, like all our high scores, and keep them all under one single variable name. Now, there are a couple of golden rules. All the items inside have to be the same data type, so all numbers or all strings, and they're all stored together in a specific order.
Okay, let's get down to the basics. Section 3 is all about the most common type of array you're going to come across, the one-dimensional or 1D array.
The absolute easiest way to picture a 1D array is to think of a single row of numbered mailboxes. Each box is called an element, and that's where you store one piece of your data. And every single box has its own unique address, which we call an index. Now here is the most important part, the thing you have to remember. In programming, we always start counting from 0. So the first box is at index 0, the second is at index 1, and so on. Never ever forget that.
Okay, lean in for this part, because this is the exact syntax from the OCR exam reference language. This is what you'll be writing in your exam. To create an array called scores that can hold 10 items, you just write array scores parentheses 10. That makes 10 empty slots with the indices 0 all the way up to 9. Then, to put a value in, you just use its index. So, scores 0 equals 1500 puts that value right in the very first slot. See? It's pretty straightforward.
And getting data out of the array is just as easy. It's a simple three-step process. You use the array's name, add those square brackets, and then just pop in the index number for the element you're looking for. So if you wanted the fourth high score, you'd use scores 3. Makes sense, right? Because we start at 0.
All right, we've totally got 1D arrays down, so it's time to level up. Let's move on to Section 4, two-dimensional arrays, or as you'll see them, 2D arrays.
So if a 1D array is like a single row of boxes, a 2D array is a whole grid of them. Just picture a spreadsheet or a chessboard. It's the same idea. And because it's a grid, you now need two indices to find any single element. You need its row number and you need its column number. This is absolutely perfect for things like game boards, cinema seating plans, or really any kind of data that fits in a table.
And here's the OCR syntax you need for 2D arrays. To create that 8x8 chessboard, you'd write array gameboard 8, 8. To place a piece on it, like a pawn, you'd write gameboard 1, 0 equals pawn. And remember, both the rows and the columns start counting from 0. So row 1 is actually the second row down.
This slide really puts it all together. On the left, scores 5 needs just one index because it's a single list. It gets you the 6th item. On the right, gameboard 5 needs two indices, a row and a column, to pinpoint a single cell on that grid. So one dimension, one index. 2 dimensions, 2 indices. It's as simple as that.
Okay, let's lock all of this knowledge in. Section 5 is all about the absolute key facts you have got to remember for your exam. These points are straight from the OCR specifications, so they're pure gold.
Let's do a quick rapid-fire recap. 1. Arrays are 0 indexed. I've said it a lot because it's that important. The first element is at index 0. 2. In the world of OCR, arrays are fixed length or static. That means if you make an array with 10 slots, it will always have 10 slots. You can't just add an 11th. 3. They only store one type of data, no mixing and matching. And finally, the syntax. One index for 1D arrays, my array of X, and 2 for 2D arrays, my array of x, y. Got it?
So the bottom line is, arrays are fantastic. They are perfect for managing lists and grids when you know the size up front. But that leaves us with a pretty interesting question, doesn't it? What happens when your data needs to grow, or when it doesn't fit into a neat grid? What data structures do we use then? Well, that is the next exciting step on your computer science journey.